Okay, so this is lesson 7 about distance. We're going to use the Pythagorean theorem to help us find the distance between 2 points on a coordinate plane. It is the length of the line segment that connects them. The Pythagorean theorem can be used to find this distance. So we're going to use the Pythagorean theorem. D stands for distance squared equals x1 minus x2 squared plus y2 minus y1 squared. So when we talk about, when I say x2 with this like little 2 down here and x1, we actually look at where x is down here. And like this is, we talk like this, it doesn't matter. We can say that this is the second point and this is the first point. You can flip those around just as long as you stay consistent. So if this is my first point that I'm talking about, and this is my second point that I'm talking about, let's like label those A and B. So this is point A. It has x1 and y1 as its coordinates, or as its ordered pair, and then this is x2, and we're just like labeling them y2. So I find this is x1 right here. So the x is, so this ordered pair is 1 and 4. And this ordered pair over here is 8 and 8. So this is x1 and this is y1 and this is x2 and y2. So I would plug those numbers in to find the distance. So because this is d squared, it would be whatever d times d is equals this. So you can actually simplify that by saying the square root of that. So we're going to go ahead and just do this one as an example before we get started with these. So if I have 1, 4, and we're saying that this is x1 and y1, and then my other ordered pair is 8, 8, and we're going to say that this is like, this is point A and this is point B, x2 and y2. Okay, so there, and then let me write my formula down really quick. D squared equals x2 minus x1 squared plus y2 minus y1 squared. So there's my formula for finding the distance between those two. And so I'm going to plug those numbers in to solve for this. So I'm going to continue to write D2 and just plug these numbers in. So this is x2 is right here, 8 minus x1 squared plus y2, 8 minus y1 squared. So now I'm going to take away this squared right here. I'm going to put all of this underneath a square root, and I'm going to solve for these as I'm doing that. So this equals 7 squared plus 4 squared, and then continue on. 49 plus 16, D equals 49 plus 16, the square root of 65, which is not a perfect square, so you can leave it as that, or, solve for it, 8.06, or you can say, well, that's pretty close to the square root of 64, which is 8, so then you can do your estimation like we did in the lesson before to figure that out. All right, so the example down here has this ordered pair as -3 and 4 and 6 and -1. So this is going to be tricky because it's got negative numbers in it, but I know you know how to add and subtract your negative numbers, so that shouldn't be, and multiply and divide, so it shouldn't be that big of a deal. So we plug those numbers in. I'm going to do it down here just because I like to have a little bit more room. So this is -3 and -4, 6 and -1. And so because I'm going to say that this is point A and this is point B, we're going to say that this is x1 and y1, and this is x2 and y2. So my formula is up here, so I can just plug those numbers in. I'm not going to rewrite my formula. So D2 equals x to 6 minus x1 minus a negative 3 squared plus y2, which is negative 1, minus y1, which is 4 squared. So d2 equals, you saw for this, now two negatives make a positive, so this is 9 squared plus, and I'm going to take away that, well, it doesn't matter, I'll leave that d squared. And then this negative 1, this is like plus a negative, so this is negative 5 squared. So now I'm going to take this away and just say it's d and put this underneath a square root. So this is 81 plus a negative 25. So d equals the square root. What's 81 minus 25 equals 56. This 56 is not a perfect square, so you can leave it as the square root of 56, or you can estimate it. What did we do wrong here? Oh, sorry, that's what I did wrong. So negative 25 squared is actually 25. Sorry, because it's negative 5 times negative 5, which would equal positive 25. So this is actually the square root of 106. And so you can use your calculator, 106 square root 10.3 rounded to the nearest tenth. Or you can say, well, that's pretty close to the square root of 100 and try and figure it out through that. Okay, what is the distance between negative 2 and 0 and 5 and 0? All right, so you're going to say that these are the 1s and these are the 2s. So my equation is d2 equals x2, which is 5, minus x1, which is negative 2 squared, plus y2. You always start with the 2s. You're taking the 2s away from the 1s, but it doesn't matter which one you decide is 2 and 1. Just as long as these are the 2s, they are both the 2s. If these are the 1s, they are both the 2s, or both the 1s. So this is the y2, 0, minus y1, which is 0 squared. So d squared equals, this is actually 7 squared plus 0 squared. Take away this square and put this inside the square root, 49 plus 0. So d equals the square root of 49, d equals 7. All right, what is the length of the segment of the line shown below? All right, so we've got to figure out this right here. And so I'm going to say that this is point 1 and this is point 2. So these are going to be my x2, y2, and this is x1, y1. So I've got, we're just going to follow these steps down here. So substitute the coordinates of the endpoints. The distance formula equals d equals the square root of, excuse me, x2 minus x1 squared plus y2 minus y1 squared. All right, so we're going to substitute the corners, or the coordinates. This is x2 right there, and x1 is right there, and then y2, this one, and y1, this one. Okay, so now we need to solve for these. So they have the same thing written right here. So we're gonna solve for these. So this is, ooh, owie. Oh, they made the 2, so this is really 2 plus 2, and this turns into 1 plus 5. And so 4 squared plus 6 squared. So 4 squared is 16, and 6 squared is 36. 16 plus 36 equals 52. The square root of 52 falls between the square root of 49 and 64. So you know it's going to be 7 point something. I think we've actually already done this one. So 7.2 times 7.2, that equals 51.84. That's pretty close to 52. So I'm going to say 7.2. So the length of the segment is the square root of 52, or about 7.2. Explain how to find the distance between the 2 points on a coordinate plane. Well, you use that cool distance formula. So you find the difference between the x coordinates and square, and add to, I guess you find the difference of the square of the x coordinates, and then add to the difference of the y n squared, and then find the square root. And then find square root. How does the distance formula relate to the Pythagorean theorem? Well, the Pythagorean theorem is a squared plus b squared equals c squared. So like in reality, like this c is the d squared. So like what's inside of that square root is this part, and then the c squared would be that d squared, or the distance. So like if you look at that formula, this is c squared equals a squared plus b squared, right? It's kind of the same idea. And when you look at the distance, like what you're actually doing here is forming a right triangle. And this right here is like A, this right here is B, and this is the distance, which is C. All right, so you're gonna use that equation to find the distances on these. I would recommend using another sheet of paper to do it, and save that paper too, just in case when we go over this, you make any mistakes, or I make any mistakes, we can check it together. Find the distance between each pair of the points, leave answer in radical form. Radical form means in your square root, so to leave it in here. You don't have to estimate it to the nearest tenth like it asks you to do here. So when you have to estimate your square root to the nearest tenth, you can use your square root button. It's totally fine to do that. All right, over here, find the distance between each pair of points, leave the answer in radical form, so leave it in your square root form. And so what is interesting is this part right here. So like this would be x1, y1, x2, y2. And so this 5 square root of 2, this is actually 5 times the square root of 2. So to figure that out, you would need to find out what the square root of 2 is. And I would just round it to the nearest tenth. So 2 square root is 1.4 is how I would do that. So this would be 5 times 1.4. 1.4 times 5 is 7. So this x1 is 7. And then I would leave the square root of 2 as just 1.4 and do the work from that. And then same with these. I would find the decimal form of these. This is x1, y1, x2, y2, and just find the decimal forms of these to do the work. Or I guess you could leave it in fractional form, and then eventually simplify it into the decimal form for the end. So maybe let's do that one together. All right, so we have d squared equals x2, 6 minus x1, which is 8 over 3, squared plus y2, 3 minus y1, 5/3 squared. So d2 equals, And so that's the problem here is like 6 minus 8/3. What is 8/3? So 8 divided by 3 equals 2.6 repeated. So I would change it into decimal form. Plus 3, and what is 5 divided by 3 equals 1.6 repeated. So I guess round it to 1.7. So d squared equals 6 minus 2.7 equals 3.3 squared plus 3 minus 1.7 equals 1.3 squared. And then d, put this inside of a square root. 3.3 times 3.3 equals 10.89 plus 1.3 times 1.3 equals 1.69. D equals, add those together, square root of 12.58, which then on your calculator, but it does say keep in radical form, so I would just say square root of 12.58, or about, because we rounded those numbers to the nearest tenth. So I wouldn't even put that equal sign, I would put about. All right, and then you've got 3 awesome word problems here that you're gonna have to plug those numbers in and figure out the distance between the 2 points on the coordinate grid. So this is hard stuff, but as long as you follow the formula and you use all the knowledge that you've got from square roots and radicals, that you should be okay. Let me know if you've got any questions over Google Chat or email.